Write the order of boiling points of the products formed in the following reactions, and the reactions are given by that is 1-butene on reaction with HBr in presence of benzyl peroxide. Similarly, 2-methyl 1-propene on reaction with HBr, butyl-2-ene on reaction with HBr. Whereas the first case, that is peroxides, benzyl peroxide is a radical because it undergoes easy cleavage due to peroxide bond. It makes the HBr to be present in the radical form. As a result, it undergoes crash effect, that is peroxide effect. In the crash effect or the peroxide effect, which is eligible for the HBr, Br minus, that is Br radical, initiate the reaction. As a result of initiation of the reaction with the Br radical, because Br radical is free, Br radical on reaction with the starting material, it generates relatively stablest radical, that is secondary radical formation takes place. This secondary radical once again participates in reaction with the generated H radical. Thus, it generates into the formation of what? 1-bromobutane formation takes place. This is our compound A. Let us feel this as A. Yes, I am writing here a line also to not to get any kind of confusion. Whereas HBr addition under normal condition is electrophilic addition reaction. H plus will initiate the reaction. So as a result, it generates. So this H plus initiates the reaction. Stablest cation, that is H plus attacks over here. Tertiary carbocation generation takes place. On this tertiary carbocation, Br minus makes an attack. Thus it results into the formation of what? That is 2-bromo 2-methyl propane formation takes place. Whereas in the next case also, here H plus will initiate the reaction. It generates this one as stablest carbocation like this. On this, Br minus will makes an attack as a nucleophile. So therefore 2-bromobutane formation takes place. Hence, let us claim this as compound B. Let us claim this as compound C. In compound A, that is a linear chain containing of primary bromine at one of its end with 4 carbon atoms. This is also 4 carbon atoms but connected to the tertiary carbon with the bromine, and this is 4 carbon atoms linear combination in which bromine is connected to the secondary carbon. So if I go for A, if I go for B, if I go for C, whereas in A like this structure is present, in C this is tertiary butyl connected with the bromine, in C on the secondary carbon bromine is connected. So therefore whenever it is connected to the primary carbon, there what happens is lot of length is present. Moreover here much electronegativity differences will be generated. The chain length is so length that in the entire lengthy part of the carbons followed by bromine, there is a chance for it to make van der Waals interactions with the others. As a result, this A maintains highest boiling points. Whereas the second case, that is the last one, C, compared to this one, the length will be somewhat little because bromine is present on the secondary carbon. Whereas in the last case, that is B, in case of B, what happens is that is tertiary carbon. As being it is tertiary in nature, the clumsiness increases. The total material is deposited within the small space. As a result, here boiling point will becomes what? Decreases. Thus, as the length of the same number of carbons containing linear length increases, size increases. Size increases implies its ability to make van der Waals interactions with the others increases. Thus in this case, lot of van der Waals force of attractions can be existing of one with respect to the others. Suppose in this case, the size is became very spherical. The shape, the three-dimensional available volume for the molecule is reduced to very little. So therefore little interactions are existing with the others. Hence little van der Waals forces of attractions makes this one as very low boiling point containing substance.